Now third one, current shunt feedback. So a normal current amplifier will be working as a current shunt feedback amplifier. You know, common emitter amplifier is going to amplify your current. So I guess C amplifier can be considered as an example for current shunt feedback. So from the name, input side, I'm going to have shunt mixing. Output side, I'm going to have current sampling. Current sampling now, I have to take current from series. Output side, you see, current is taken, whatever current flowing through RL is going to flow through my feedback network. And the input side, I'm going to connect across. See here, input side is shunt mixing, so I'm going to connect across. In shunt, voltage is same, current will be different, so you can apply KCL here. Okay, so notation 1, it is called as current shunt feedback. Notation 2, it is called as shunt series feedback. Again, this conversion from N1 notation 1 to notation 2, you have to be very, very clear. If I say current shunt, you should be able to say the next name for it. What is the name in notation 2? If I say the notation 2 name, you should be able to spell out the notation 1 name for this feedback configuration. Okay, you have to be very fluent in converting from notation 1 to 2. That is very, very important in understanding the characteristics of the amplifier.